Section 4.8, Scientific Notation. The goals of our lesson are that we can convert numbers between scientific notation and standard form, and we can also multiply and divide large numbers if they are converted to scientific notation. Scientific notation is a way of expressing really big numbers or really small numbers. It is most often used in scientific calculations where the analysis must be very precise. Scientists use this every day in their field, and you will be using this in science classes moving forward. Scientific notation consists of two parts. The first part, our n, is a number between 1 and 10. The second part is a power of 10. More specifically about the first part, or the n, that number could be equal to 1. However, it absolutely must be less than 10. To change a standard number into scientific notation, this is a slide you will want to write down word for word, pause, and rewind if needed. You will place the decimal point so that there is one non-zero digit to the left of the decimal point. You will count the number of decimal places the decimal point has moved from the original number. This will be the exponent on the 10. This will make a lot more sense when we have an actual example, I promise. If the original number was less than 1, then the exponent is negative. If the original number was greater than 1, then the exponent is positive. Let's take what was just explained in the last two slides and apply it to some examples as we change the following numbers into scientific notation. Again, you're encouraged to pause and rewind and try the examples as we go along. We start with this number. And what I like to do is literally take my decimal point and move it and count the spaces out loud as I move. 1, 2, 3, 4, 5, 6, 7. I now have a number in which only one non-zero digit is left of the decimal point. That becomes the n. I know I am multiplying it by a power of 10. Since the point moved 7 times and the original number is really small, -7 is the exponent. Let's try another one. We have the number 480,000. Our decimal point in a whole number is always to the right of the final 0. So we place it there, and we're going to count. 1, 2, 3, 4, 5 places. So now our n becomes 4 8/10 as we have one non-zero digit to the left of the point. We have a power of 10. The point moved over 5 places, and since the original number was large, we know it's positive. 4 8/10 times 10 to the 5th. I encourage you to pause the presentation here and try this one on your own as I go ahead and solve it. I'm going to move my decimal point over 2 places. So again, only one non-zero number is to the left of the point. I have a power of 10. The point moved 2 spots. The original number was less than 1, so the exponent is negative. We are now going to convert the following numbers from scientific notation into standard form. So for this, we just work the exact opposite way. We have our starting number, which I like to write out, 4 89/100. The exponent is +7, so we know our number is going to get bigger. We are going to move our decimal point 7 places out. Watch as I go beyond the 9 what I do. 1, 2, 3, 4, 5, 6, 7. I leave those buckets there to remind me that I need to place zeros in the open spaces. Now, if you want to rewrite the number so it looks a little neater without the drawing, you can. This also helps me remember where my commas go. So this number converts to 4,890,000. Let's try another one going the other direction. So we have our original number, 1 4/10. Since our exponent is -8, we know our number is really small. So our point moves to the left 8 places. 1, 2, 3, 4, 5, 6, 7, 8. And again, those buckets remind me to place zeros there. So I know that I've told you I don't want to hear the word point in here when describing numbers, but when they're this small, I think I can make an exception. So we have 0.0000000014. For the next one, I would like you to pause the presentation and see if you can solve it on your own. I'm going to take our original number, 3 789 thousandths. The exponent's positive 5, so I know we're getting bigger. The point gets moved 5 places. 2, 3, 4, 5. 0 still the buckets. I'm going to rewrite the number as 378,900. This is a good time to refer back to the notes you copied down earlier regarding the proper form of scientific notation. We want to know if the following numbers are in proper scientific notation form. Remember that form we saw? N times 10 to the x, where 1 is less than or equal to n, but n is less than 10. So we look at our first number, and right off the bat, I notice that 29 is bigger than 10. Therefore, this number is not in scientific notation. I look at this one. Well, 2 9/10 definitely fits our criteria. However, our exponent with 10 is not an integer. So this would be a no as well. And just to clarify, we say the exponent is not an integer. Finally, we look at this example. Well, 2 9/10, that is between 1 and 10. Our exponent is an integer. Therefore, this one is in scientific notation. We will now combine what we learned in sections 4.6 and 4.7 by multiplying and dividing exponents with our new information on scientific notation. I want to know how we can multiply this number, 7 6/10 times 10 to the -4th times 4 8/10 times 10 to the -6th. This is one long multiplication problem, and therefore we can rearrange the terms any way we'd like. So let's rewrite the problem so our like terms are by each other. 7 6/10 times 4 8/10 times 10 to the -4th times 10 to the -6th. We multiply our decimal terms like normal, and hopefully you have calculators and you find this answer to be 36 48/100ths. And for our exponents, remember, when we multiply exponents with the same base, we add the exponents. -4 plus -6 is -10. And finally, we have to make sure our final number is in scientific notation. Unfortunately, it is not. Our decimal point needs to move over one spot to the left. So our end term becomes 3 and 6 and 48 thousandths. I'm sorry, 3 and 648 thousandths. And as for our exponent, since we made the original number smaller, the exponent has to get bigger by the amount of spots we moved over. So since the point moved over one spot, we have to add 1 to our exponent. We are now in proper scientific notation. We will end the lesson by dividing numbers in scientific notation. We have this problem: 5 and 46 hundredths times 10 to the 28th power divided by 6 and 5 tenths times 10 to the 24th power. If you recall from our lesson 4.7, we can divide out like terms. So I'm going to go ahead and rewrite the problem so it looks like a vertical fraction, which we are used to. Five and 46 hundredths divided by 6 and 5 tenths becomes 84 hundredths. And then 10 to the 28th power divided by 10 to the 24th power becomes 10 to the 4th power. This is the quotient we are left with. We must ask ourselves, is this number in scientific notation? And hopefully we recognize that it is not. Our decimal point must move over one place. So we have one whole number to the left of the decimal point. So we have 8 and 4 tenths for our end term. We know we have 10 to some power. And since our whole number got larger one spot, we have to drop the exponent by 1. So our final answer is 8 and 4 tenths times 10 to the 3rd power. If any part of this lesson was unclear and you have further questions, please have them prepared for Mr. Kreinberg tomorrow in class. You are also encouraged to go back and review any of the slides that you may have missed or just want to see for a second time.